Good morning. My name is Tungatarov, and I am Kyrgyz. And I have a question. Have you ever had that mysterious feeling that something in the world isn't actually the way we think about it? Well, all of us experience that feeling at one point in our lives. And that feeling caught the famous scientists who contributed to the quantum theory. The theory that occurred to be so bizarre that no one took it seriously at first. The quantum theory and the theory of general relativity are the two main postulates of modern physics. So why don't we dive into the unexplored world of quantum physics? The heart of quantum mechanics circulates around the wave-particle duality, and surprisingly, it all started with a light bulb. In the early 1900s, Max Planck was to make most of the energy a light bulb emits into visible light, so that most of the energy of a light bulb wasn't taken by low-frequency infrared light or heat. He failed to do this many times until he came up with an idea that light, instead of being a wave, comes in discrete chunks which he called quanta. He theorized that high-frequency light comes in huge packets of energy, that it is capricious. That is why most of the energy of a light bulb is taken by low-frequency light, which is glad to share the energy. Imagine energy as pizza and friends as quanta. Of course, there will be more friends that will get one slice each. This was a good explanation for why high-frequency light doesn't take all the energy from an object, leaving it as cold as can be. Later, as Einstein picked up this idea, he discovered the photoelectric effect. He proved that light was actually a stream of particles by shining it onto a metal surface and observing how it knocked loose electrons. That meant that light was a wave and a particle at the same time. Later, this wave-particle duality was given to all other particles. That means that everything in the universe is a wave and a particle too. But that is not the same thing that happens in quantum mechanics. It occurs that until we measure a particle to be a particle, it behaves like a wave. And there's a great experiment that proves that. When we fire one particle at a time through a narrow slit, they randomly land on our detector screen. We detect it, and it's a particle. It appears random because it travels like a wave. Imagine waves as ripples on water, and the particle as a piece of dust traveling on a river. But when we start firing one particle at a time through two slits for a long period of time, we see a wave-like pattern and still detect particles on our screen. This happens because those ripples interfere with each other, and most of the time push the dust particles in the place of interference, thus creating an interference pattern. This proves the wave-particle duality of objects. But it creates a question: how did those particles create such a pattern if we were firing one at a time? It is as if they travel as a wave of all possible positions before entering a slit, and as a single particle after coming out of a slit. And that state of all possible positions is called a superposition of states. That means that an object exists only as a wave of probability in a superposition of states before measurement, and as a physical object after measurement. In other words, it's everywhere at once until we find it. It's as if our measurement determines the reality. As Niels Bohr once said, it is meaningless to assume reality with the absence of observation. Remember when I said earlier, until we measure a particle to be a particle, it behaves like a wave. What I meant was, if we measure the same thing but in different ways, we'll get different results. If we measure a quantum object spin on a horizontal axis, it will be spinning up or down. But if we measure the same object spin but on a vertical axis, it will be spinning left or right. But actually, the world of quantum physics holds much more into it than what we discovered. There's quantum tunneling, quantum erasers, quantum entanglement, quantum multiverses. But isn't it the new science that drives us into new understanding of our existence? It seems like nothing in the world gives more pleasure than understanding for what purpose we were created. Maybe we will never know, but what I know for sure is that while the universe and life in it exist, while we endlessly challenge our minds, we will never stop learning, creating, filling up the empty, and doing what we were created to do.